Assalamualaikum and hi everyone. Today we will build a simple reaction timing game using an LED and push button. Before that, don't forget to subscribe to our channel. Stack Raspberry Pi Pico on the breadboard. Connect the Pico's 3.3 volt to the positive power rail of the breadboard. Then, connect the Pico's ground to the negative power rail of the breadboard. Next, take an LED. You will see one of its legs is longer than the other one. The longer leg needs to be connected to Pico's GPIO 15 via the resistor. So, take a 330 ohm resistor and insert it into the breadboard in the same row as Pico's GPIO 15, which is at the bottom left, and the other end into the same row as the longer leg of the red LED. Then, insert a male-to-male jumper wire into the same row as the shorter leg of the red LED and connect it to the negative side of the breadboard's power rail. Next, add the push button into the breadboard. Take a jumper wire and connect one of the legs to the pin GPIO 14. Then, connect the other leg to the positive side of the breadboard's power rail using a jumper wire. Lastly, insert another push button into the breadboard. One of the legs is connected to the GPIO 16 at the bottom right of Pico, and the other leg is connected to the positive rail of the breadboard. Okay, now we can plug a micro USB cable into the micro USB port on the Pico. Then connect the other end of the micro USB cable to one of the USB port on our Raspberry Pi 400. Now, to program this game, we need to use Tony Python IDE. Make sure to choose MicroPython Raspberry Pi Pico. Okay, let's start to program our reaction game. As usual, import machine so we can control our Pico's GPIO pins. We need to import the uTime library so that we can handle everything to do with time. And we will also import a uRandom library that handles creating a random number. In the previous video, we are using thread for the push button. This time, we are going to use interrupt requests or IRQs. Unlike a thread, the code isn't continually running. It only runs when the interrupt is triggered. Okay, now we will define a handler for the interrupt. The code will only run when the interrupt is triggered. This simple two-line handler starts by turning the interrupt off so that it only triggers once and then prints out information about pin that responsible for triggering the interrupt. Rather than using a fixed delay, this line makes use of the uRandom library to pause the program randomly for between 5 and 10 seconds. This line is to set up the interrupt. The interrupt requires two things, a trigger and a handler. The triggers tell Pico what it should be looking for as a valid signal to interrupt the program. In this case, IRQ rising will trigger as soon as the button is pushed. IRQ falling will trigger only when the button is released afterwards. The handler is the one that we have defined earlier in our program, the code that runs after the interrupt is triggered. Click the Run button and save the program to our Pico as reaction_game.py. The LED will light up. That is our signal to get ready with our finger on the button. When the LED goes out, press the button as quickly as we can. When we press the button, it triggers the handler code that we wrote earlier. Look at the shell area and we will see our Pico printed a message confirming that pin GPIO 14 triggered the interrupt. Mode in tells that pin was configured as an input. Now, to make it more interesting and fun, we will add time to measure the player's reaction speed. This line is to create a new variable for the time to start to count when the push button is pressed. This line will print the result of the time taken for our reaction speed in milliseconds. This line is to create another variable that provides a reference point, the time just after the LED went out and just before the interrupt is triggered by the push button. Click the run button again, wait for the LED to go out and push the button. This time we will see a line telling us how fast we press the button. Now, let's modify the code a bit so that we can play this game with our friends. Set the first push button as the left button and the second push button as the right button. Make sure to create the handler and interrupt for the left and right buttons. Click the run icon. Wait for the LED to go out, then test the push buttons to see if both of them work. To make the game a little more exciting, we can make it report on which of the player was the first to press the button. This sets up a new variable fastest button and set its initial value to none because no button has yet been pressed. These two lines allow the function to change. The fastest button variable will read and store the details of the pin which triggered the interrupt. This creates a loop, but it is not an infinite loop. These two lines tells MicroPython to run the code in the loop only when the fastest button variable is still 0. Finally, this line will let us know which player is the winner. Press the run button and you can start to play this game with your friends. That's all for today. I'm Suat from Cytron Technologies. Thank you for watching.